Let's talk about Accelerate. I just started using this book last semester. The reason why was last summer I was part of a group that was advising a multinational corporation out of Europe on how to upgrade at least some of these divisions, certain divisions of the corporation, on how to upgrade their software practices. Sort of wanted to know what were best practices. And fortunately, I was working with a lot of people who knew what all the best current practices were. I was there mostly to do some wordsmithing and help put the documents together and do stuff that I'm really good at there. I actually made my living as a writer at one point, so I can write fairly well. But I learned a lot, and one of the senior software engineers that I was working with recommended this book, and I bought it and read it and thought that this is very much what you need to know, because what it does is a research-based assessment of the most effective practices that are currently out there. Now, as a reality check, I had my son-in-law, John Hicks, who works very actively in DevOps environments, listen to my lectures from last year or last semester and say, okay, am I touching base? And he said, yeah, actually, you're doing a good job, which was nice. He said there's more in-depth stuff, but his caution was very interesting. He said, here's my observation. A lot of organizations, and if this may sound familiar with stuff we've talked about so far, he says a lot of organizations say, we're going to do DevOps, so we're doing automated testing, and we're setting up stuff on Amazon Web Services, and by golly, we're doing leading edge DevOps. Part of what this book makes clear is that the real change has to be a cultural change. It's not the tools, it's the culture. And that's always been true. I will contend that if given a hand-picked set of software engineers, we can use command line C compilers on MS-DOS and write great software. It's not about the tools. It is about the culture. It is about the discipline. It is about being able to envision what you are doing and carrying it out. Which is why you will hear me say time and time again, the thing that matters most are the people, not the tools. Okay, so this is by Nicole Forsgren, get the names correct, Jez Humble and Gene Kim. Data collected over a 4-year period, surveying a lot of organizations. This is part of what I like about this. This isn't, a lot of what you hear about, this is what you should do, or this is what you shouldn't do, is sort of based on, this is what I think you should do, or this is what I think you shouldn't do. They actually surveyed a large number of organizations and did follow-up surveys and follow-up surveys, both to assess the productivity of those organizations and to see what practices appear to be tied to them. This is a very research-driven book. That's why I'm making you read it. They have 5 categories of capabilities. We're going to talk about these. And as always, I assume that you've read the book, or if you haven't, that you will read it. Oops, wrong direction. Okay. What do they mean by accelerate? Faster turnaround, higher quality, greater customer experience. That's it in a nutshell. The ability to respond quickly. I know a number of you have been working. How many of you have been in situations where you've been asked to make some change to an existing system and it has taken months to get the change in place? Yeah. The focus at Accelerate is changing stuff that day. Having things set up so, and part of it is by taking smaller bites, what they call smaller batches. A lot of software is done on a big bang approach. Here are 20 pages of requirements. These are all changes we want you to make or features we want you to add. Get them all in, test them all, and you do that, and by the time you actually work through the 20 pages, they have another 15 pages for you. Or they've changed their mind on a third of the items. One of the core concepts here is that of small change, automated testing, highly automated integration, and the ability to respond quickly when you make a mistake. Anyway, go to the next slide. Okay, how to measure performance. What they term a high-performance organization. Lead time, delivery in less than an hour. In other words, if you put a change in, you can actually get it into production in less than an hour. Deployment frequency, on demand, and if you're updating constantly, multiple times a day. In other words, you want an environment where you could actually not have to go 3 months and then do a big release or rollout, but where you can actually have changes occurring multiple times in a single day. Mean time to restore means the ability to roll back a change. Usually because you've introduced an error. So this becomes a high performance issue because the simple truth is you're going to roll out bugs. Especially if you're on a very fast pace like this. And what you want to do is be able to snap back. And you want a very low change fail percentage, so you don't have to do that a lot. Now, what their observation is, and they have nifty little box charts, when you have high performance software delivery, it impacts the organizational performance. That is, organizations that have high performance software delivery make more money. They gain market share. They can beat the competition. And you have non-commercial performance, meaning non-bottom line. At least not directly, meaning the stuff you put out there is better. Your customers are happier. Your developers are happier. Now, COTS and software as a software. COTS stands for commercial off-the-shelf software. Microsoft Word is COTS. Actually, Microsoft Word is now sort of software as a service. You have to pay an annual. If you have Office 365, you pay an annual subscription. The update stuff and so on. But the idea here, and we've mentioned this before, it's the buy versus build. You don't want to spend your time and resources building stuff that you can get off the shelf or as a service. You don't want to recreate GitHub. You don't want to build from scratch your own bug database. You certainly don't want to build your own word processor or text editor. You want to find best of market in terms of what suits your needs and buy that and focus your development efforts on the things that make you competitive in your market. This is an important concept. It's one that a lot of organizations have struggled to learn, but most of them have learned. Things are quite different. You go back 20, 30 years, you would still find corporations building their own accounting system instead of simply buying Oracle Financials, or actually, I'm sure Oracle Financials around 20, 30 years ago. There were some other mid-sized accounting things. You don't have time to reinvent the wheel. Buy the stuff that allows you to get your work done, and then build the stuff that allows you to own the market. Questions or comments so far? Does any of this not make sense, or does it make sense? Yeah.
I know later in the chapters, I understand the idea of not reinventing the wheel. They talked about how it's more expensive in some cases to use third-party software, and you want to bring it in-house. When do you want to do that versus?
Well, you actually touched on one of the question was what happens. Where are cases where you may want to actually bring the software in-house rather than use a third-party product? If the third-party product is too expensive or doesn't meet your needs. If you go all the way back to Mythical Man Month, you may recall that Fred Brooks talked about a craftsman is known by her or his tools. So if you can't find a tool that does exactly what you want to do, you build your own, either from scratch or by adapting or wiring together or extending some third-party tools. So but the trade-off is always, where is our time and money best spent? Will this be a continuous source of pain? It's a bit like, I trust all of you at some point have been walking with a rock in your shoe. Okay? And as you're doing that, you have this decision to make. Do I want to stop and take my shoe off and dump the rock out, put it back on and tie it back up and then keep walking? Or am I going to walk the 100 yards to my next class, put the rock in my shoe and worry about it then? Software is often like that. And if it's a sunny day and you're not in a hurry, it's like, yeah, I'm going to sit down and take off my shoe. If it's pouring rain and you've got to be at your next location in 5 minutes, you grit your teeth and endure the pain. You have the same sort of trade-off as to when you buy versus build. Do you take the quick solution, or do you do you spend the time and effort to go with something else? Okay, downside of continuous development, continuous integration. This was just like, what, 3 days ago, 4 days ago? This is me posting on Facebook. And I was on Facebook, and it's a little wonky today. It seems sluggish. Now, it's kind of hard to see here, and I don't know if I can easily enlarge this. But this is my friend Matt Ewan, who grabbed a screen grab of this post, and this is what he saw. So desktop. And let me enlarge this. Can you make out the date there that he saw on my post? December 31st, 2010.
Oh, did you post it back then too?
So he was seeing a bizarre date on the post where I was complaining about his Facebook looking wonky. Facebook does a lot of CI/CD, and this is often the result. How many of you have had the experience with Facebook or with other online systems where suddenly it starts behaving strangely? Yeah. I'm probably on Facebook more than you guys. It's an old folks thing. It does. It'll be fine. It'll be fine. And all of a sudden, it's like getting a rocket shoe, where it's like suddenly my tire flat. There's something wrong here. My car is sort of bumping as I drive along. And then it clears up. The downside of CI/CD is you often push stuff into production that isn't ready for prime time. And the trick is how quickly does it get backed out and fixed. Got backed out fast enough that, now I never actually paid attention to what the date was there, so I'm not sure when it got corrected, but you can see Matt was able to capture this almost immediately. Now, this is probably, of the first 6 chapters, this is probably the most important chapter, because as I said, what matters in the end is culture. And I'm going to skip ahead momentarily to this one chart. This is the Westrom organizational culture models. I have been in all of these cultures. These are very real differences, the 3 types of cultures. Have the power-oriented, the rule-oriented, and the performance-oriented. Power-oriented is one where management is management by power. You will do what I say. It is kingdom building. It is trying to see how many people you can be supervising. This is where you have the thermocline of truth, because anyone bringing up bad news gets whacked for it. There are a lot of cultures like this. I have a post, and if I think hard enough about it, I'll post a link to it over on Slack. I think I've already mentioned this actual case. We're talking about thermoclimate proof. That the Air Force was trying to consolidate its 130 some odd accounting systems and spent 7 years and $1 billion and abandoned the project without having actually changed anything. And one of the principal reasons actually cited in the postmortem review of the failure was that middle management was afraid to deliver bad news upwards because they were punished for it. And so you just had this ongoing system where the people below the thermocline knew things weren't happening, but every time they tried to tell people up above, they were whacked on the head. This is a classic, you know, I don't want to hear about problems, I want to hear solutions. I posted a link, and I can't recommend this, at least not officially, but has anyone else watched the Netflix documentary on the Fire Festival? This is classic project failure. I mean, if you've taken this class and you've watched this documentary, by 5 minutes in, my wife and I watched it, 5 minutes in I said, oh, this is so screwed. It's already clear that this is going to fail. I'm already seeing the warning signs. And it was almost painful to watch because the results were utterly, utterly predictable. And they just sort of soared off a cliff, and it was boy, it was ugly. Anyway, but that was literally one of the things. You had the guy who was in charge of it, the one who's now in federal prison, had people coming up to him and trying to say, look, we can't do this, or we don't have that. And his response literally was, I don't want to hear problems, I want to hear solutions. There is no solution for this. We're out of money, we don't have food, we have hundreds of people showing up here, we don't have a place for them to stay. Anyway, bureaucratic and rule-oriented. A lot of organizations follow in this. It's more where the messengers are neglected rather than shot. This is a bit like the story I told about Eric, where they wanted to shift to weekly bills, but they had this thick binder methodology that required all these very formal steps. And the bottom line of that was that programmers had basically 1 day a week to code. Then all this paperwork they had to do on Monday, they could code on Tuesday, but to follow the process, documented software methodology, they had stuff that tied them up all day Wednesday and all day Thursday. Then they'd do a build on Friday. So the programmers were coding exactly 1 day a week, which is one of the reasons they weren't making much progress. Creative performance, high cooperation at all levels. Messengers are trained. Those people are all told, here's the danger signs to look for, come tell us when you see them. That's a novel concept, but that's a very good concept. It's a lot of what I do as a consultant. Except I'm the one who's sort of going around, talking to people in the trenches and saying, okay, tell me what's happening. Tell me what's working, what's not working. And as I've said before, I can usually tell within a day or two exactly where the problems are. And what the true state of the project is. It's not there's anything magic. I just talk to the people and I listen to them. Risks are shared. Bridging, that is reaching out to people outside of your particular group, is encouraged. Failure leads to inquiry. So many organizations do not, when they have a failed IT project, do not do a formal post-mortem. That's your best chance to learn. And in fact, you have two key problems here. One is they don't do a post-mortem, the other is they don't fail fast enough. If a project is in trouble, you want to know that. You want to pull the plug as soon as possible. And figure out, okay, let's not waste any more time and money on this. Let's see what's going on, decide whether or not we're going to continue to do this. With all the failed projects I've reviewed, time and again, you have the sunk cost fallacy. Oh, I've already spent $1 million on this, so let's give them another $500,000. Another 6 months to be able to get this into production. You know what happens? It almost never works. Because they have not looked at why the project wasn't done after the first year, $1 million. Yeah.
Yeah, but in one of my economics classes, they teach you that you ignore some costs when you're planning on doing everything else. So is economics just misguided, or?
Oh yeah. Well, it's really an ego thing. It's like, oh, we spent all this money, we don't have anything to show for it, we don't have any working code. But if we just spend another $500,000, we'll have working code and the system will work. And the problem is occasionally that actually happens. You do sort of limp along. Maybe you just misunderestimated things. And you spend a little more time, a little more money, and you actually get it out the door. Pages was a year late in shipping, but we shipped. And we shipped multiple versions. Sadly, we were shipping to an operating system that had no real installed base. That's a whole other debate. And novelty. Here you have novelty meaning suggesting doing something new. In the power rated, it's crushed. Bureaucratic, it leads to problems because it's just not by the book. With a performance-oriented system, novelty is like, okay, let's try this out. Now, remember all our other lectures, you don't try out new things on high-pressure, mission-critical projects. You try them out in little batches. You do little pilot projects or projects that aren't as important and see whether or not your new approach, your new technology, your new tools work or not. Let me ask you this, and if you feel you want to raise your hand, if you don't, that's fine. A lot of you on your projects are using technology that you've never used before. Whether it's an engine, a language, operating system, whatever. If you have the semester start over again, how many of you at this point might consider using something you were more familiar with? Yeah. Are you all on the same team?
Yeah, we're all
Yeah, I wish we hadn't used done that. Okay, technical practices, continuous delivery. You want to be able to make changes safely, quickly, and sustainably. You don't want to introduce rot or instability. And if problems show up, you want to be able to back out quickly. Now, how many of you have actually worked in a continuous integration, continuous delivery environment? Okay. Tell me about what it's like when it's actually working well, for those of you who've had that experience. Anyway?
Yeah, so it's just really, really cool to, well, I don't really know how to explain what it feels like. You find a problem and you fix the problem, you commit it, you push it, you have your teammate review it, your team lead if necessary, you push it, and it's fixed in production just within a couple hours.
Yeah.
I mean, if you have, we call them pulses where I work. A pulse is an error problem. The pulse comes in, somebody gets the notification, they go fix it, push it up, and it's fixed. And it's just really relieving that the process is so fast.
And what kind of flexibility do you end up having as far as the actual product or system as a result?
Well, if you screw up, you can just go back, or you can make some other change within a matter of minutes.
Yeah. So that's what you want. That's what a high-performance organization is like. Trust me. A lot of projects, and I assume a lot of you have worked on projects where it is not quite that quick and smooth. I certainly have. Once again, and along the same thing of buy versus build, use computers for repetitive tasks, use humans to solve problems. So part of CI/CD is really looking and saying, what can we automate? What is repetitive? What can be done by a computer? This automated test, but it's more than automated test. You want your configuration management system to make it very easy to step back. You've committed an error, you've committed code, and it has an error, and you basically say, okay, let's go back one version. Let's roll that back out. Or, in circumstances, this is something that I don't know how many of you have experienced this, often you actually do need to be able to maintain multiple releases because you have different target hardware, or you have customers or clients who rely upon an earlier version and are basically, they have systems that interact that depend upon features that are in an earlier version and not your latest version. And so you want a highly automated configuration management system where you can basically dial up, say, I want version 2.4.1, targeted at Windows 7. And you push a button and your configuration management goes through and builds that and gives you a nice binary bundle which can then be deployed on Windows 7 and has that feature. So you want the fully automated configuration management, continuous integration. It is common, well, and I suspect some of you may have experienced this in your projects this semester or in prior semesters. When you're programming on a team and someone grabs a copy of the source code and makes changes and they don't check those changes in until 2 weeks later, and meantime everyone else on the team has been checking in changes, and then they go to check in their changes and either they step on the stuff that you've done and wipe it out, or you have this big reconciliation fest where it's like, well, I was depending on this, well, we dropped that 3 days ago, so now we have to do this. The idea of continuous integration, often called trunk-based development, is that as much as possible, you maintain the source code in a trunk, and as per very short-term changes, if I'm going to change something, I grab it, I make the change, and I put it back in almost immediately. Very, very short time frame between when I grab the source code and then when I check it back in with changes. And you want to continue, oh, yeah.
How does that work with code review? Does someone, I mean, if you're like pushing and pulling often, doesn't you have to like review that often as well?
Well, yeah, you grab someone and say, I just did this.
Oh, really? Okay.
Yeah,
So they should
and
be
this is why you want small batches. In other words, the part of the advantage of this approach is that you try to make the changes as small as possible. You're fixing a bug, you're modifying one feature,
So
you're
the
doing
code
something.
review shouldn't take that long.
Yeah, so it's like, okay, I'm doing this. You grab someone and said, this is what I did, here's what it was, here it is now. Do you see any problems? And the person who's doing code review says, yeah, well, you might do this. It's like, oh yes, that's a problem.
Okay.
Or they say, no, it's fine to me, and then you check it in. It breaks and you have to buy everyone donuts. That's what we used to do at Pages. Break the bill, you have to buy donuts. Yeah.
Kind of on that point, when I was working at my internship, we basically would do this, and we would be doing code reviews probably, I would have to review someone's code probably once every hour or two. But like, it was short reviews, it was less than 5 minutes, but it was very, very much a constant.
Yeah. So and actually that's one of the most effective ways of doing code reviews. Is really just get another person to look at it and explain to them. Same way how I've described, that's one of the most effective debugging techniques. Is just grab someone and say, here's the bug, here's what I'm doing, here's what I think it is, and I had the experience, I don't know how many times in my life where I'm halfway through describing what it is, and it's like, oh, never mind.
Okay, I figured it out.
Yeah, I figured it out. And the person's like, yeah, happy to be of service, and walks off. Okay, technical practices. These are technology and practices that support CD, and hang on a second. Okay. We're not going to go through these in great depth because I assume you're actually reading the book. But among the technical practices, you want to look at a version control, deployment automation, that is, stuff gets pushed out when it's ready for production. Continuous integration, trunk-based development, test automation, test data management, that is, you want a system. You don't want ad hoc testing. You want a system where your test data, you not only have automated tests, but your test data is under source code control or has some sort of management system so you can pull up the right test data for the tests. Shift left on security, which is their touchy-feely way of saying you actually have to build security and you can't do it after the fact. And this is such a disaster, you know, because we're pushing software out onto the Internet of Things, and most of it, the security is crap. It really is. It's appalling at pretty much what we have done in terms of flooding the world with smart devices that have minimal security on them. Loosely coupled architecture, we'll talk about that in a minute. Empowered teams, monitoring, and this is not looking over your employees, this is actually having instrumentation that monitors the system in production. This is a long-standing practice. I did some reviews at a financial corporation for their existing systems, and they had actually fairly sophisticated monitoring software for customer-facing websites so that they could tell what kind of load they had, you know, what the responses were, what the queries were, what seemed to work well, what you know, occasionally ended poorly, and so on. Proactive notification, let people know when things go wrong. And often this is tied to monitoring tools for systems in production where someone gets a message. Go back 20 years, you get stuff on your beeper. Now you get stuff on your phones or stuff on Slack. Now, what happens when you adopt continuous development? What the authors have found, you get higher quality. You get happier employees. Developers don't like to ship bad software. It's frustrating. It's frustrating to push something out with bugs or something that's poorly designed. You get a higher delivery performance, which is along the lines we've talked about. You get strong team identity. In other words, the stuff that Accelerate helps in the team building that DeMarco and Lister and PeopleWare said was so essential. It's like we're doing good stuff here, and our stuff works, and we can turn on a dime. Lower levels of development pain and reduced team burnout. Burnout can be a real thing. I went through burnout. Now, in my case, it was when I was doing Sundog Frozen Legacy and Oasis Systems. Worked really long hours to get the 1.0 version out. And then we started working on, fixed a bunch of bugs from the 1.0 release. Released as 1.1, then was doing 2.0. Which wasn't a second game, it was just simply the next, somewhat improved version of the original game. And there were things I was very unhappy about at work. I won't go into the details and so on. But long story short, it took about a little over 6 months to release 2.0. We shipped it. I resigned a week later, and I did not program for money for 4 years. I was so burned out from coding. I tried. I had someone who wanted to hire me to do game development, and I started to work on that. Fortunately, they didn't actually hire me. They were trying to do it on a contract basis. And I got about 3 weeks into it, and I threw up my hands and said, I just can't do this anymore. Now, by great good fortune, I had a side career writing and was able to switch to writing full-time back when you could actually make a nice full-time living. My salary actually went up when I doing a monthly column for Byte magazine. But it was 4 years. And the first programming I did for money in those 4 years, after 4 years, was a contract programming gig at Apple, short term, and I thought this is sort of safe and I'll see what I can do, and it went fine. I basically went back in programming. Then I did Pages, where I worked 60 hours a week for the first 3.5 years, including occasional 100-hour stretches, and I never burned out. I'm not sure why that is. I think it's because I felt more in control. That I really, as chief technical officer, chief software architect, I felt more in control. I was pushing myself because of me, and I wasn't doing it all by myself, which is pretty much what it was about. But burnout can be a real thing, yeah.
This is a random question. Did you ever meet Sandy Peterson? He was kind of like a game developer. Right?
Yeah, well, again, wasn't he with KSCM? Didn't he do Call of Cthulhu and so on?
Yeah, and he was like a one designer doing stuff.
Yeah. I don't know him personally, but I certainly know his name. So burnout can be a real thing in the wrong situation. Architecture. Let's see how we're doing. We're doing fine here. We're going to wrap this up, take roll, and then we'll be done for the day. Yeah, a lot of coding to do between now and Monday. The goal, and this is a good goal anyway, the goal is a loosely coupled architecture. For high performance, what you want is not an architecture that's one big massive ball. You want a number of loosely coupled modules. You can have high internal consistency and cohesion, but loose coupling among them. And the reason why that's so tied into high performance organizations is because it means I can make change. You can think of it as a bunch of balls with APIs connected. I can make changes within one of these balls, and as long as I don't change the APIs, everyone else doesn't matter. It's when you have an architecture where if I make a change here, I have to go through and make changes in 5 different places that you slow down your performance. But as much as you can isolate the different components of the architecture, you can do this. So they give the goals as to what you want to do, so on and so forth. It's a good list. It's a good chapter. Read it. The interesting thing that they point out, and I think with justification, is that with a well-designed, loosely coupled architecture, you can violate Brooks' law. Because you can add people to a new component without impacting the people in all the other components, because they really don't care when you get an API. That's how you get around Brooks' law, is by having the interfaces well enough defined. Now that takes good architecture work. Because usually the first thing that happens when you have an API is people want to change it. It's like, well, can you add a feature that does this? Or can you just add this parameter here? And let me do this as well. Yeah.
So I see how you can do that in the back end with microservices, but how do you do that in an app or Dynamics? Is it just really difficult?
You use patterns, model view controller, you do different patterns where you can separate the stuff. Now, the question is, what are the loosely components? If the front end is one component, then it's one component, and you're not going to get around it. And there's an old saying, I think it goes back to Don Knuth, who probably deserves credit for it, whether or not he said it, who says there is no issue of complexity within software engineering so hard that it cannot be eased by adding a layer of indirection. The corollary is there's no performance issue within software that is so hard that it cannot be eased by removing a layer of indirection. So you have this inherent tension. The more you try to break up your architecture to more and more loosely coupled modules, you start to impact the overall system in different ways. You have more communications, you have more performance issues, and then when it comes time that, well, we're running this and it's running 10 times too slow, what do? You start grabbing modules and smashing them together so they can talk to each other directly. It's a trade-off. Let's go back to Armour's diagram. That's the reality you live with. And frankly, in my own personal opinion, it's why I am totally unconcerned, as I've been for 40 years, about AI taking over programming. Because really, that's the issue. You know what AI is good at? It's good at the rote stuff that you can already write software for anyway. What AI is not good at is coming up with elegant, extensible, conceptually unified architectures and the specific problem solutions that will make things work. Now, AI sometimes comes up with problem solutions, genetic programming, stuff like that, but it's really interesting what happens there because people go and look at the code and they can't figure out how it's doing it. One of the best and earliest examples of this, if I can digress for just a second here, I'm going to get you out of here quickly, don't worry. There was a project, gosh, this is like 15, 20 years ago, over in England. And they were basically trying to use genetic programming. Do you know what genetic programming is? Basically, you're doing natural selection. You're getting software that gets closer and closer to a solution. And you get one to finally solve it. They were using these little gate arrays, programmable gate arrays. And the idea was they wanted to build an A to D converter. And they were using genetic program with this array of gate arrays and having them change and feeding the analog signal in and pulling the digital signal out and continuing to do this until they started getting it to work. And they finally got it to work. So they said, aha, let's see what it does. You know what they found? There was no data path from the analog side to the digital side. They're like, wait, this is impossible. How is this happening? So they went back in and they dug, and what they found was happening was that there was, among adjacent gate arrays, there was some RF interference that was being caused by the processing here that this one was picking up and interpreting as the signal coming from the other side. So there was no direct connection, but this one happened to be responding to the RF radiation coming off this one. And it worked. And they said, wow. Didn't prove useful. It wasn't a good design to actually put it in production. But it was sort of like, oh, well, that's what's happening. If you do some reading and research on some of the machine learning and adaptive programming efforts going on currently, you'll find there are similar issues where you have algorithms that have trained themselves to accomplish certain things, and humans are going in and they can't quite figure out how it actually works. Conway's Law. If you're going to do a loosely coupled architecture, make sure your organization supports it. Build a team so that the team structure and communication structure reflects the architecture you want to build. They also say that teams should be allowed to choose their own tools within reason. Architects should focus on engineers and outcomes, not tools or technologies. Often architects get very tied into, and this is the tool I want you to use. So this is the approach. Whereas an architect should say, here is the outcome we want the software to be. Here are the concepts to build it. This is how it's structured such that things can communicate. And as it says here, what tools and technologies you use is irrelevant if the people who must use them hate using them, or if they don't achieve the desired outcomes. Now that may seem obvious, but trust me, that really happens. Integrating information security. Make your software secure. Okay, that's the chapter. No, seriously, it's, you have to build it in from the start. There are things that you really have to plan for from the start. Security is an important one. So, by midnight this Saturday, submit your latest status report, watch one podcast, we'll do the rest of Accelerate. We'll go through Webster 7, and we'll have your demos next week. We'll have midterm in 2 weeks. Let's take roll, and then I will let you guys go out of here.